Welcome to part 2 of displacement time and velocity time graphs. In this video, we're going to quickly look at 5 commonly asked test and quizzes questions on displacement time and velocity time graphs. If you would like to see the creation of the displacement time and velocity time graph shown in this video, please watch part 1. Question 1. What is the total displacement of the student over the 8 seconds? Try to answer this using both graphs. To answer this first question, we have to understand what is meant by the displacement. The displacement is how far we end up from where we start. So this is very easily answered on the displacement time graph. On the displacement time graph, we started at 0, which was our desk, and we ended at 0, which was our desk. So on the displacement time graph, our displacement was equal to 0 meters. If we look at our velocity time graph, we're going to have to do a little bit more of an in-depth analysis. We have to sum all our areas, and direction matters because it's displacement. So our first area is 2 meters. Our third area is minus 4 meters, and our fifth area is 2 meters. So on our velocity time graph, our displacement equals 2 meters minus 4 meters plus 2 meters, which equals 0 meters, and confirms our answer from our displacement time graph. The second question is, what is the total distance traveled by the student over the 8 seconds? What this question is actually checking is, do you know the difference between distance and displacement? Well, distance has no direction, so it's just the total amount that you travel. So if we first look again at our displacement versus time graph, we have to add up all the distances that the student travels. So in the first second, they travel 2 meters. Then they don't travel any meters. Then they travel minus 4 meters. But when we're calculating distance, direction doesn't matter. So this is just 4 more meters that the student traveled. So now in total, the students travel 2 meters plus another 4, which makes 6. Then to get back to the desk, they travel another 2, making a total of 8 meters traveled. If we look at our velocity time graph, we can come to the same conclusion. Here, we calculated the displacements, so all we have to do is now sum the areas, but direction doesn't matter, so we ignore the negative sign. So the total distance traveled by the student on our velocity time graph is 2 meters plus 4 meters plus 2 meters, which equals 8 meters, and confirms our answer from the displacement time graph. Question 3. What is the student's displacement after 6 seconds? This question is easily answered looking at our displacement time graph. So if we look at our d versus t, all we have to do is look at 6 seconds. And where is the student at time 6 seconds? Well, the student's at a displacement of -2 meters. It's a little bit more work if we're looking at our velocity versus time graph, because here we have to figure out which areas we're summing. So at 6 seconds here, that means we're summing this area and this area, and that's our area 1 and our area 3. Because it's displacement, direction matters, so our area 1 is 2 meters and our area 3 is minus 4 meters. This gives us a total displacement after 6 seconds of -2 meters, which confirms our answer from our displacement time graph. Question 4. At what time or times is the magnitude of the student's velocity the smallest? The way this question is presented makes it a little bit of a trap. Students are often tempted to say that the student's smallest velocity will be -1, forgetting that in physics, negatives just indicate direction. So a velocity of -1 is the same magnitude as a velocity of +1. It's just moving in the opposite direction. So when is the student's velocity the smallest? Well, it's when they're not moving. It's 0. So between 1 and 2 seconds on the velocity time graph, and between 6 and 7 seconds on the velocity time graph. If we look at our displacement time graph, we have a velocity of 0 when we have a slope of 0. This would be, again, between 1 and 2 seconds and between 6 and 7 seconds, just as we saw on the velocity time graph. The fifth and final question is, what does the slope of a velocity versus time graph show? To answer this question, we again look at the units of the slope. So slope, again, is equal to rise over run. In a velocity time graph, our rise is equal to a unit of meters per second, and our run is equal to a unit of seconds. Meters per second divided by seconds gives us meters per second squared. And these are the units of acceleration. So the slope of a velocity time graph shows acceleration. All of our slopes are equal to 0, and this is because we were always moving with constant velocity. We didn't have any acceleration in our question. Thank you for watching the video on displacement time and velocity time graphs.